So yesterday, when we were working on these questions, we were asked to sketch graphs. And the way I was showing you to sketch graphs was able to put it in its factored form, right? Where we had this equation where it was y is equal to a bracket x minus r n bracket x minus s, right? That was that general form that we were dealing with. What was r and s? Your x-intercepts, not your x and y, but just your x-intercepts, right? Now, how can you find your y-intercept? Well, you can plug in 0. Guess what happens when you plug in 0? You multiply a times r times s, right? So you can find your y-intercept by just multiplying your a times r times s. That gives you your y-intercept. Then you can put in those points. But how did we find the vertex? Because that's important when you're graphing it. Oh, because I changed the question. Okay. So there's an equation. We have to find that midpoint, right? The axis of symmetry. And so we had an axis of symmetry formula. That's what she's getting at. Good. Really good memory. So the axis of symmetry formula, do you guys remember? X is equal to R plus S, your axis of symmetry, or your x-axis, divided by 2. Now, that axis of symmetry doesn't always have to be the x-intercepts. It's just got to be 2 points on the parabola that are on the same level, okay? So it doesn't have to be your x-intercepts. It just has to be 2 x values that are on the same level, okay? Now, let's go through this question. So in this question, it says sketch the graph of negative x squared plus 6x minus 9. So we took a negative 1 out. Well, now we took a negative 1 out. So it says positive x squared minus 6x plus 9. Okay, so I changed the question a little bit just so that we were able to factor it. Okay, and the questions that I give you like this, if you want to solve it like this, they have to be factorable, right? In some way or another. Okay, so how can we factor x squared minus 6x plus 9? Well, we got to look at what times what will give us positive 9 and add to give us negative 6. Any answers? Negative 3 and negative 3. Okay. So we can write this as negative 1 times x minus 3 times x minus 3. All right, you guys. We're just making mistakes all over, because what is this then? This is a trinomial square, and this is a case where that is our vertex, is it not? Because x minus 3, that'll give us, if we solve, one x-intercept at x is equal to positive 3. Okay? So that's our vertex then. Okay, so it's not going to be able, we're not going to be able to find the axis of symmetry using that formula because we know the axis of symmetry already. The axis of symmetry is going to be x equals 3, right? Because if that's the vertex, the x value of the vertex is the axis of symmetry. Okay, so this makes this slightly harder to come up with information to graph it, but it doesn't make it unable to graph it. Okay, so let's continue on writing what we know now. We know that if we solve for this, x minus 3 equals 0, x is equal to 3. So this is 3 comma 0. This is our x-intercept, right? We know that. But because there is only one x-intercept, that tells us what? What does it tell us? When there's only one x-intercept, it is the vertex. That's what it means. So now we have a vertex at 3, 0, and we also have the axis of symmetry, right? Is x is equal to 3. So, if we are going to graph this, we only have 1 point to graph. Can we do anything with 1 point to graph? 3, 0. We only have 1 point to graph. Can we do anything with that? Not really. We have this axis of symmetry that comes down here. Sorry, it should be straight in there. What else do you know? Going back to your old school ways, what else do we know? You can always find the y-intercept, right? The y-intercept is a times r times s, right? Which is -1 times -3 times -3. So that gives you -9. But remember, you guys, if it's written in standard form, it's just whatever the standard form was. So -9, right? Or a times r times s, which is still -9. Okay, so many different ways we could find the y-intercept. We're using our new method, but we could always go back to old methods. So our y-intercept is -9, so that's 0, -9. So if I was going to sketch that as part of my graph, I'd have to go down 1, 2, 3, 4, 6, 7, 8, 9, right here, right? Bring down my axis of symmetry. Can I graph the parabola now? Half of the parabola, what do we know about parabolas? They're symmetrical, so we can graph the one half and then graph the other half, right? How far is this y-intercept away from the axis of symmetry? 1, 2, 3. So if I go 1, 2, 3 over, right on that same x plane, we're going to get the symmetrical point for that parabola. And then we can sketch it, because sketching is just kind of what does it look like. We don't need more than 3 points to sketch a parabola. As long as you have one vertical point, one vertex point, and 2 that are symmetrical x values. Okay? And there is our parabola. Nicely sketched. Arrows at the end. Domain for this thing. Now I'm going back old school. Domain for this thing. X such that. Okay. The only time this changes is when you're dealing with word problems, right? And you have to think about the situation then. Because sometimes you can't have negative x values. Sometimes you can't have x values greater than 50, right? Just depends on the situation then. What's our range? Some people struggled with range still. Is it going to be greater than or less than? All our y values are less than a certain number, right? Y such that y is less than or equal to, what's the highest y value? 0. Y is an element of the reals. Okay. Sometimes we throw old school stuff in. Okay. We throw domain, we throw range, we throw old standard finding that y-intercept in, right? Just because we learned it last week doesn't mean you can't bring it back, right? If I really wanted to check my sketch, what would I do? I would head up to the top and I would type this very first one, -x² plus 6x minus 9, into my graphing calculator. Does it look like the same thing I got? Sure. Or I would go second graph and look at the tables and see if I got the same points. Okay? Now, what if I give you a question like this, where it says, find the equation. We have x-intercepts, don't we? We have a y-intercept. We have a vertex, but do you know what that vertex is? I didn't give you enough information for that vertex, did I? You can guess on the vertex, but you don't know for sure. So what happens if you don't know the vertex? Well, you can't put it in vertex graphing form then, right? So what's our new form? Y is equal to a bracket x minus r bracket x minus s. Okay? And what's r and s? Your x-intercepts. So what's my x-intercepts? Here it's -1, 0. And here it's 4, 0, right? Those are my x-intercepts. So if I plug them in, I get y is equal to a x minus a minus 1, which turns into plus 1, and x minus 4, which is just x minus 4. Woohoo! Am I done? No. What do I have to do? I have to figure out my a value. So I can do this a couple ways. I can put in this y-intercept point. What's this y-intercept point? 0, 2. Okay. So I can put 0 in for x and 2 in for y and solve for a. Okay. Or I can go back to the y-intercept equation, y equals a times r times s. Right? I plug in my y-intercept formula and the r and the s and solve for a. Either way will give you the same answer, so I'm going to show you both. Okay? So the first one, plug in 2 for y equals a bracket x is 0, 0 plus 1 times 0 minus 4 gives me 2 equals a. 1 times -4 is -4. How do I get a alone? Divide by -4, and I get a equals -1/2, right? Same thing over here. I could have solved for the a value, my y-intercept. The y value was 2. A, the original r is -1. The original s is +4. And that gives me 2 equals a times -4 again. Divide by -4, you get -1/2 again, right? What do I have to do with this a value? I was supposed to come up with the equation, right? That was my goal. Where's my original equation? Well, it's right up here, right? I just didn't know what a was. So now I know a. We just have to insert -1/2 in for a. So the equation of this graph that they gave us is -1/2 x plus 1. Sorry, these are brackets. X minus 4. And that would be the equation of the graph that was drawn for us. Okay? One more question. I'm going to show you a word problem. Okay? So, with this word problem, it deals with pierogies. We were talking about Ukrainians yesterday, hey? Thought it was fitting. The members of a Ukrainian church hold a fundraiser every Friday night in the summer. They usually charge $6 a plate of pierogies. They know from previous Fridays that 120 plates of pierogies can be sold at the $6 price. But for each dollar price increase, 10 fewer plates. What should they charge members if they want to raise as much money as they want or as they can for the church? So as much. So we're looking for a maximum kind of thing, right? So we want to look for a maximum. And they give us some information, right? They usually charge $6 a plate. 120 plates sold for that $6. Okay? But if they drop it, or if they increase it for $1, 10 fewer plates will be sold. And we want to know what the member should charge to maximize. Okay? So, there's a couple different things, but the first thing we need to remember is, what are we trying to figure out? What are we trying to optimize here? Right? We are trying to optimize money for the church. How do you figure out how much money the church makes? You take the price per plate and you times it by how many plates sold. Good. Okay. So we take the price per plate and we times it by, I just want to erase all this. Can I erase this for you guys? Okay. So we want to maximize the price. So money made is equal to number of plates times the price per plate. So what can we do this? Price per plate. Okay. Well, what's the one thing we're changing? The dollar amount per plate, right? So we're going to let Y be the money made. And why am I choosing it to be the money made? Because if I look over here, this is the major thing, right? The major part of the function, what we're trying to solve for, was the maximum amount of money. So that's what my Y is going to be. And what's the only thing we're changing? X is the number of $1 increments. Okay. So if we make $2 increments, I put 2 in for X. If I made a $3 increment, I would put 3 in for X, right? Because they're dollar increments, okay? Now, if it was $2 increments, if I put 3 in for X, that would be 3 times 2, which would give me $6 increments. But because they're only a dollar increment, the number in for X is the same number as the increment, okay? So let's start substituting what we know into this equation. So Y is equal to, how do we figure out the number of plates? There's 120 plates sold if they're sold for $6, but we lose 10 for every dollar increment, right? So it's like 120, but if we change the amount, we're going to subtract 10 times what? X, okay? Now, what's the other thing we have to figure out? The price per plate, sorry. It's $6.